Hello everybody. So this is the second video. It's going to be a very short video for your chapter 0 in the book. So we're going to start to talk about errors. These are the mistakes. In life you make mistakes, and after many years they come to haunt you. It propagates. So similar to that, when you do measurements, and because it involves a human factor, instrumental factor, and unaccounted factors, errors could happen. All I need you to do is just to have a general understanding of types of errors, and then what is accuracy and what is precision, and then just to know how to get the error percentage or to account for that error. So it could be, errors could be due to instruments, faulty instruments, or the process, or the human bias. So human bias also includes our weaknesses we have there. If our eyesight is not good, the accuracy of measurements, if it is through observation, may not be correct. So instrumental errors, procedural errors, and personal bias errors. So instrumental errors is, for an example, if you have a weighing machine and there's 0 here, and at the beginning the indicator is not exactly direct into 0, it is on this side, maybe negative side, or it's a positive, then that will count as a factor for errors to happen. So to make it 0 errors at the beginning, you have to calibrate the instrument. Okay, so you can calibrate that. For example, in England, where I originally came from before I moved to the US, there was this lady conducting business of Weight Watchers. So every person who attended these Weight Watchers were losing weight. But when the trading standards raided the place and checked it, it seems that she was moving this scale to negative every day and calibrating it in a negative way, so everybody has lost weight, so more people will come to her. So she used that calibration to her advantage, although the results were wrong. So I just told you that, so you remember that. So instrumental errors, so you can eliminate that through calibration. So when you talk about the correct value, we'll say we have 50 grams of sugar. We assume that's to be the accurate, correct value, but this all depends on the instruments and the human they have used and the procedure followed, right? So at this level, we call this is the accurate value or the true value. You can't absolutely say that is the true value universally. There are these errors involving any measurement, but we'll take that if true value is all the standard value as the true value. Then if we measure something and we got 55 grams using this machine, then if you haven't calibrated properly, the factor plus 5 showing that where it should be 50, it's showing 55 is due to the instrument. But if you fix the instruments and if it is still showing 55, then it has to be human bias because there's not much of a process involved in that, in this particular example. So the human bias could be that when we are measuring it, we don't take our hand off the scale, or scale is not held in a balanced way, different things, or we are looking at it, reading is wrong. So for an example, if you have scales like that, we'll say it's, okay, sorry. That is a measuring cylinder. Okay. You put some water in it. And we say this is the 50 ml. So water, because of the surface tension, it curves like that. Okay. So this is the meniscus. Meniscus, where you should put your eye here and look at that level, not here. That meniscus should touch the level you are wanting it to happen. So this is meniscus. So, but if somebody is checking here and telling, oh, it is 55, that's a human bias, that sort of thing, right? So when you take error, this is what you do. You take error is given by the difference between the true value and the experimental. So I put 2 lines here because it doesn't matter plus or minus, we just get the value 5. That's what it means. That is absolute error. Okay. So then if you want to express that error as a percentage or as a ratio, you can do by dividing it by the true value. So this is absolute error. Just you get the figure. Right? You can call it plus or minus depending on situation, but you don't have to. You can just say it's 5 error. Okay. Then if you're taking the relative error, or be expressed as a ratio. I'm sorry, my pen time to time stops writing. So relative error is you get the true, the difference between the true and the experimental. So true and T and E I put there. And then you divide it by the true value, you get it as a ratio, right? So that is the relative error, okay? Then the examples are given in the book, so you can check it. So actually you get the value. So 5, in this case, 5 divided by 50, you get a ratio. That's the ratio. Then we have percentage error. You can express it as a percentage error. All you do is true value minus experimental, other way. These 2 lines means no positive or negative values, then true, then you multiply it by 100, then you get the percentage there. Okay, so it's 10%. Okay, so that is how you express errors that comes as a result of instrumental errors or human bias or process. Okay, so the process errors means like if you don't follow the correct process. Like if you are adding, you have water here and you are trying to fill it up to some level and you put some acid. That's the correct way. But if you're going to put acid here first, put some water, then it could splash out, right? You don't do this process. You always put to the dilute thing, you put bit by bit acid so it gets diluted. So these are the processing. So if it splashes out, then we don't get the same volume. That's all. This is just an example. And on the other hand, if you're mixing something, you use a conical flask in titration. So if you're swirling it, it doesn't go out because it's a narrow head at the brim. So this way we secure that removal of water. So that's another way of avoiding. So that is the procedural error, because instead of putting it in a conical flask, if you put in a beaker, then we are going to do some liquid. Then when it's come to human bias, I said if the eyesight, if you are not following the correct, the meniscus example I gave you. So everybody, that's all I want to tell you about this chapter 0. This is the video 2 of the 2 videos. We'll start chapter 1 next time.